Welcome to The Explainer. Today, we're diving into a skill that's absolutely critical for any data scientist leveling up into an MLOps role: documentation. Yeah, I know, not the sexiest topic, but stick with me. If you want to build ML systems that people can actually maintain, reproduce, and most importantly, use, it all starts right here. So let's paint a picture. You've done it. You've spent weeks, maybe months, training a model. The accuracy is amazing, the metrics are off the charts. But then, crickets. Nobody's using it. Your own team is confused by the code, and the ops team just throws their hands up and says it's impossible to deploy. Sound familiar? This is such a classic failure mode in ML, and the solution isn't a better algorithm. The real culprit, almost every single time, is bad documentation, or no documentation. When docs are an afterthought, it just creates chaos. New hires, it takes them forever to get up to speed. That senior engineer who built the whole thing leaves, all that critical knowledge just walks right out the door with them. And worse, from a science perspective, your experiments become one-offs that nobody can ever reproduce. It's not just an annoyance, it's a critical project risk that basically guarantees your brilliant work will just end up collecting dust. Okay, so how do we avoid that nightmare scenario? It really starts with having the right tools for the job. So let's build out your foundational documentation toolkit. The absolute bedrock of any well-documented Python project is the docstring. Now, you've seen these before, of course, but here's the magic trick in MLOps. A docstring isn't just a comment for a human. It is structured, machine-readable metadata. This is so powerful because it means other tools can come along, automatically parse these docstrings, and generate an entire beautiful documentation website for you. This is your first and most important step toward docs as code. So where do they go? You'll put them in the 3 standard spots. At the top of the module to explain its overall purpose, inside every function to explain what it does, what it takes in, and what it gives back, and in every class to describe its role. But look, the secret here isn't just having them. It's being super rigorous and consistent about it. This discipline creates a built-in map of your entire codebase, and that becomes the single source of truth for how everything works. Okay, once your docstrings are in place, you need a tool to turn them into that nice website we talked about. For most projects, my advice is to just start with MkDocs. It's fast, it's simple, it uses Markdown, you'll love it. If your project grows into a massive, complex beast, you can always graduate to Sphinx later. And for the style of the docstrings themselves, honestly, just use Google style. It's clean, super readable, and perfect for most things. The only exception is if your work is really heavy on scientific computing and complex math, then the NumPy style is tailor-made for that. So you've got the tools. You know how to write a docstring, but what should you actually write? This is where we need to stop thinking about just writing stuff down and start thinking about strategic communication. And for that, there's an amazing framework called Diataxis. The core idea behind Diataxis is actually really simple, but it's a total game changer. It says that people come to your documentation with very different goals in mind. So instead of creating one giant, messy pile of information, you should organize your docs into 4 distinct categories, where each one is designed to serve a specific user need. And here they are, the 4 quadrants. So when a new data scientist joins your team, they're lost. They need a tutorial, a step-by-step lesson to get started. When you, 6 months from now, can't remember how to deploy a model to the staging environment, you need a how-to guide, just the specific steps to get a job done. When a teammate just needs to quickly check the name of a parameter for your data cleaning function, they're looking for reference material. And when your boss asks why you chose a transformer over an LSTM, they need an explanation, a deep dive into the concepts and the decisions. See how powerful that is? You're meeting the user exactly where they are. All right, let's bring this all back to our world. Because MLOps projects have all the regular needs of a software project, plus a whole bunch of really unique and absolutely critical documentation requirements. You see, in MLOps, documenting your Python code is just the ticket to the game. It's not the whole game. The real integrity of your project, the thing that makes it trustworthy and reproducible, rest on these 4 pillars: the data you used, the models you built, the experiments you ran, and the pipelines that tie it all together. If you neglect any one of these, your project essentially becomes a black box. And let's be crystal clear about this.
Data documentation is completely non-negotiable. You absolutely need a data dictionary so people know what feet_x_123 actually means. You need a formal schema so that bad data doesn't silently break your entire pipeline. And most importantly of all, you need lineage and versioning. Without those, you can never truly prove which exact dataset was used to train the model that's now running in production. And if you can't do that, true reproducibility is just a fantasy.
Now, for your models, you should be creating model cards. I love this concept. Think of it like a nutrition label or a resume for your model. It's a standard format for communicating everything a person needs to know about it. What's the architecture? How did it perform on different slices of the data? And, this is so important, what are its intended uses and its known limitations? This kind of transparency builds trust and helps make sure your model is actually used responsibly.
All right, you have the tools, you have the framework. Now let's talk about the habits, the pro-level moves that take your documentation from just good enough to truly great.
Okay, rapid-fire pro tips. 1. Know your audience. An ops engineer cares about environment variables. A data scientist cares about feature importance. Speak their language. 2. Automate everything. Your docs should be generated and deployed automatically as part of your CI/CD pipeline. If the code changes, the docs change with it. No exceptions. 3. Examples are everything. Give people clear, copy-pastable code snippets. And finally, 4. Document the why. Why this model architecture? Why this feature engineering choice? That context is absolute gold for the next person who picks up your project. And please, please, please remember that documentation is not just text. A single, simple diagram can explain what pages and pages of text fail to. Visualize your CI/CD pipeline, draw out your cloud architecture, show the flow of data through your system, and of course, use charts to visualize model performance. Visuals make complex systems digestible in an instant. Great documentation isn't a monument you build once and then admire. It's a living garden that you have to tend. To make it live, create a contribution guide that tells other people how they can help make it better. Establish a feedback loop, like a simple link to your project's issue tracker, so users can easily tell you when something is confusing or wrong. And finally, you must version your docs right alongside your code and models. When someone is looking at version 1.2 of your API, they need to see the docs for 1.2, not the docs for the upcoming 2.0. This prevents so much confusion. So, I want to leave you with a total shift in perspective. Stop thinking of documentation as a chore, as the tax you have to pay after you've done the real work. Instead, ask yourself this: what if your documentation became your project's single most valuable feature? The feature that drives adoption, that enables collaboration, that prevents disasters, and that ultimately determines whether your work makes a real impact. Because in MLOps, that's exactly what it is.